is any object that is only under the influence of gravity. So, for example, here we have a long jump runner, and you can see her. Right now, she has a velocity only in the x direction, and she is able to push off the ground with her feet, and so she is not a projectile. But as soon as she jumps, a couple things happen. First of all, she's no longer in contact with the ground, so the only force, the only thing that's acting on her is not her muscles, it's just gravity. And so we call her a projectile. Now, her speed, her velocity, once she jumps, she has both an x velocity, she's still traveling in the x direction, but she also has a y velocity. And because of that, we have to use vectors to describe her motion, since it's in two different directions, which is why we spent the first 5 videos of this unit kind of understanding vector math, because now we see that a situation like this has both a y and x component. Now, these velocities are independent of each other. And that's very, very important. So we're going to watch a couple videos here that it's going to show you how these two things are independent of each other. Okay, what you're going to see in this first video is a cart that's going to be traveling from right to left on your screen. And here, we'll show the video, and we'll talk over it as it goes here. Okay, so let's watch it. Watch it in slow motion. Okay, and what I want you to notice is at this point, right, the cart is moving with a velocity in that direction, in the x direction, right? The ball is also moving with a velocity in that direction. Because it's part of the cart, they have the same velocity in this direction. But then the ball also gains an upward velocity because it's shot from the cart. However, this upward velocity has no effect on the velocity in this direction. Therefore, the ball is able to keep moving right along with the cart and falls right back down into the cannon, or whatever you want to call that, right? So this y velocity has no effect on this x velocity, because if it did, the ball wouldn't fall right back down into the cart. It would fall either in front or behind. But as we see here in slow motion, it falls right back in the cart, which tells us that these two velocities have no effect on each other. They're independent acting agents. Now, let's watch the second video. This one's really cool. It's one of my favorite Mythbusters. In this Mythbusters, what's going to happen is they're going to take a bullet, and some of you may have seen this. This is really cool. They're going to take a bullet. There's a bullet. And one bullet they're going to shoot from a gun, so it's going to have a velocity in this direction. Another bullet they're going to just drop, so it falls straight down. Both bullets will start from the same exact height, and the gun will be aimed exactly parallel to the floor, right? So parallel to the floor, right? So they start from the same height, and what you're going to see, because this velocity in the x direction has no effect on the y component, or the y velocity of the bullet, that this bullet will fall at the same rate that this bullet falls, which means they will hit the ground at the same time. Even though this bullet's moving at an extremely, extremely high speed, the y component of its velocity is not affected by this, so bullet 1 and bullet 2 both hit the ground at the same time. If you don't believe it, it's hard to believe. Let's watch it and see if this will make you a believer. Not a believer, though. Well, unless you are a believer. I'm not.
What you got there?
This is a good one. Picture two bullets, each exactly the same distance from the ground, each released at the exact same second, except one bullet is dropped to the ground, the other is fired from a gun. The classic physics thought experiment states that both bullets will hit the ground at the same time.
Based on what theory?
Based on the theory that the bullet that's fired from the gun has no wings on it, no lift. Thus, gravity has the same effect on it as it does on the drop bullet, and thus, they hit the ground simultaneously.
Adam lays down a runway of white paper so the high-speed camera will clearly see and measure both bullets at the same time, in the same place, and in the same shot. All we need now in the drop zone is Jamie's drop rig, so the boys can take a shot at physics history.
All right, dude, you ready to do this for real?
I think we'll hit it on the first shot.
Really?
Oh, yeah.
You never make predictions. That's awesome.
Bullet dropped versus fired. In 3, 2, 1.
But from 360 feet away, the boys can't see exactly where the fired bullet landed.
Let's go see where it hit.
So Adam takes a one-wheeled ride down the room to check out the drop zone.
Wow.
And the results are simply ripping.
Can't get much closer than that. Ugh. I can't wait to see the high speed.
Adam analyzes the high speed and crunches the numbers.
3677 minus 3915 equals 238 divided by 6. Dude, the difference is 39.6 milliseconds.
Which means it's less than the human eye can make out.
So after days of brain-teasing tests, the Mythbusters can claim a world first for themselves and a victory for physics.
Let me put 39.6 milliseconds into some perspective for you. When you go to the movies and watch a projected celluloid film on the screen, you know that that film's made up of individual images, right? What you might not have known is that it takes 24 of those per second to make up the film that you're watching. So each one is on screen for exactly 1/24 of a second, but you don't notice that because it's faster than your eye can register. Well, that 1/24 of a second is actually longer than 39.6 milliseconds. That's how close those two bullets were.
All right, so hopefully seeing was believing, and in the next video, we'll learn how to take that knowledge that the velocity in the x direction and the velocity of a projectile in the y direction are independent, and we'll learn how to do that and put those kinematics equations we learned in season 2 to good use in a projectile problem and predict things like how long a bullet will be in the air, how far it'll go, some really cool stuff. So I know that video was fun, so I don't even have to say it this time, but I'm thinking it. But I'm not going to say that I hope you had fun. I'm just going to think it.